the timer. Hello, everyone. This is Xianjun from IMAC as well, I would say. Yeah, I'm currently still working in IMAC in Belgium. I work in the ID lab inside IMAC. The location is in Ghent in Belgium. So I will introduce what is Openwifi, what are the progress now, and what is the plan, and finally some open questions. So what is Openwifi? Well, I guess some of you might heard about Openwifi recent days, but we are not that. Openwifi, the global open access Wi-Fi system. Yeah, we are the free and open Wi-Fi chip design. Fortunately or unfortunately, the name are collide with each other. But here, Openwifi is a open source or free Wi-Fi chip design. But currently, it's not a real chip yet. It's still run on the FPGA platform, together with some off-the-shelf analog R frontend to do the verification. And it's also used a lot in our internal research activity. And meanwhile, we also release it in free and open source world under the HGPL v3 license on GitHub. You can just search Openwifi, you will find our GitHub. I think our item is on the top in the Google. Here in this page, you can see the we already got lots of users on GitHub according to our observation. If some people come to us to ask a question or to discuss some features, we know they are actually using Openwifi. Most of them, I think, are from universities, research institutes in the US, Europe, Asia as well, and also Australia, I think. Also some industrial companies, but they are in well, you know, the traditional companies in the traditional business model. On GitHub, our software plus hardware repository already achieves lots of results. I would say around 2K stars and around 300 forks and many watches. The software here means the Linux driver and our user space control tool, a small tool for people to access the driver and the FPGA. Hardware means the FPGA design. Most of our design are written in Verilog. I believe Verilog is still the most popular chip front-end development language now. Maybe in the future it could be Chisel or Spino HDL, but now I think it's still the Verilog is the most popular one. Now, if you check the topic, Verilog topic on GitHub, our project is at the rank 2 or rank 3. Well, if you are interested in using Openwifi instead of customize it, develop it, actually it's quite simple. You just download our Linux image from GitHub and buy an off-the-shelf FPGA board, right? It's not from us, it's the commercial FPGA board. And you flash the image to the SD card, insert SD card to the board. Meanwhile, connect your board to your home broadband router and then to the internet, right? Then power on. You can see the SSID Openwifi, and you can connect it to surf on the internet as the real Wi-Fi router. But you do need to check your local macro power ISM band regulations. I believe the current SDR platform we support, the transmitting power is well below 1 milliwatt, but you need to check your local regulations if you really want to use it in the open air. A different country or different region, they have different regulations, I think. But I think in most of the locations, most of the countries, well below 1 milliwatt in ISM band should be okay, but do check your local regulation. Progress. In this slide, as you can see, the project born outdated because when the project was born at the end of 2019, actually before that, we already have 2 or 3 years internal development in European research activity. Orca. But at the end of 2019, we decided to release it in open source. At that time, we support only 11AG, born outdated, right? Because as you know, AG was there 20 years ago. Then we try to catching up the state of art. The 11N is the first step under the funding from NLnet. Now we support 11N now, which is also known as Wi-Fi 4. And now we are working on the packet aggregation feature on the 11N. The packet aggregation is a key essential feature for the Wi-Fi system. It's imported in the 11N, and then after 11N, the aggregation is a mandatory feature. By default, it's on for the AC and AX. And now we are working on the AX, which is also known Wi-Fi 6. By the end of this year, we hope we can release the basic Wi-Fi 4, Wi-Fi 6.5 physical layer implementation. And we also are working on the MIMO feature. When it gets stable and mature, we will release it. And now the project, beyond the standard stuff, we are also becoming unique compared with the COTS Wi-Fi chip. For instance, we have dedicated on chip Wi-Fi CPU connection, right? In the same IPGA SoC. We have real-time and low latency. And we also support the CSI sensing and anti-CSI sensing. It's CSI fuzzer. We can prevent the unauthorized CSI sensing. And we as SDR platform, we support IQ sample, but not like other SDR platform. They always stream all the IQ to your computer continuously. In Open Wi-Fi, you can do the IQ sample capture by trigger. Because you know in the Wi-Fi chip, there are lots of trigger conditions you can define event inside the protocol. And fuzzing, you have full access to the low-level, deep-level stuff. You can do a low-level, deep-level fuzzing. And your idea, your applications matter. If you can come up with new feature, new idea, very unique, very special things, I think that would make the Open Wi-Fi more special. And I think that's also very important. Okay, finally, some open questions. From open source project, actually from our current IPGA design to a real chip, I would say not just click the button, but according to the previous several presentations from the chip form makers, from the LibreSilicon, I feel that, well, something exciting is happening there. But again, EDA software design process, design flow involved heavily, not just to click the button. We need people, we need resource and funding. And another very important question is about sustainability. Actually, I mean the commercial success. I think that's also a very important aspect of the open source project or the liberal free project. Because the commercial success could spread the good things all over the world, right? Much widely, much broadly than just volunteer-based or funding-based. So can Open Wi-Fi chip be a successful business? Because if we analyze the current Wi-Fi chip market, it's purely game of the volume, right? Then to achieve a certain the volume, can we identify a new area like a blue sea, or we jump in the already the red sea with those big Wi-Fi chip makers? Where should we go, and in which case can we win the game of the volume? Yeah, that's my presentations.
Thank you very much, Hyunjin, for this insightful presentation. I think the open questions that you've been raising are very interesting. Maybe some things we could also consider for the discussion afterwards. For the sake of time, we are a bit cutting it close, of course, always with these online events, with events in general. I would like to now give the floor to Charles